This presentation is going to cover the Wilcoxon rank sum test. This test is done when we are comparing two groups of different entities that differ from each other on some variable. This test is the equivalent of a non-parametric independent t-test. The question becomes then, if it's similar to the independent t-test, why isn't the t-test used? This test is used over the t-test when the groups are too small or if we are not sure if the data is normally distributed in each group. In order to determine whether or not the data is normally distributed, you can use a histogram and also check for skewness and kurtosis. If the data is not normally distributed, then use the Wilcoxon rank sum test. The example provided in the book looks at participants who were either given ecstasy or alcohol, and then their depression level was compared over 2 days, Sunday and then Wednesday. The total group had 20 participants, with 10 in each group. How the test is done. First, you're going to have to arrange the scores in ascending order and attach a label to remind you which group they come from. If there is no difference between the groups, then you should find a similar number of high and low ranks in each group. And if you were to add up the ranks, then you'd expect the sum total of ranks in each group to be about the same. Then, starting at the lowest score, assign a potential rank, starting with number 1 and going up to the number of scores that you have. These are called potential ranks because sometimes the same score occurs more than once in the data. These are called tied ranks, and these values need to be given the same rank. So all we do is assign a rank that is the average of the potential ranks for the scores. You'll see an example provided. Within the sample, we have 2 scores that are the same. The potential rank for those scores are listed 1 through 5. The actual rank would take the average of rank 2 and 3 and make those the actual rank. When all the data is ranked, add up all the ranks for the 2 groups. The lowest of these sums is the test statistic. Finally, you need to determine if the test statistic is significant. In Stata, to do this, you would just run a rank sum test. To do so, you would type rank sum, the variable name, comma, by, and then in parentheses the grouping variable. This will give you the t-statistic and the p-value for the test. If the test is statistically significant, then there is a difference between the groups.